Let's see how to enter beams in CYPE 3D. To do this, we open the bar menu at the top of the interface and select New Beam. The pop-up window first displays the active layer to which the element will be assigned once it has been entered. In the diagram on the right, we can adjust the layout of the section with respect to the entry line by clicking on the center, edge, or corner marks. If any beams have been previously entered in the model, the program allows us to select one of the sections used in the table below. If we are entering a beam for the first time, or if we wish to describe a new section, we click on the central button. In the pop-up window, we can indicate the family and type of beam to be entered, its dimensions, and its properties. We are going to describe the types of beams included in the available beam families, among which we find the following. Flat beams are beams that have the same depth as the floor slab. Here we find the flat rectangular beam, flat T-beam, flat beam with right flange, and flat beam with left flange options. Flat beams adopt the value of the depth of the adjacent floor slabs, which can be defined from the Edit Beams option. Therefore, in this section, the program only requests the width. If the beam is located between two floor slabs with different depths, it will assume the greater of the two. If it is located between two floors at different levels, the depth of the beam will be increased to reduce the difference in level. Dropped beams have a different depth to the floor slab. Therefore, if we select the dropped rectangular beam option, we must indicate its width and its depth. If we activate the beam below slab checkbox, the top face of the beam is aligned with the bottom face of the slab. If it remains deactivated, it will be aligned with the top face of the slab. In the dropped rectangular beam with collaborating head, we also indicate the length of the left flange and the right flange of the concrete section that will work together with the beam. The inverted rectangular beam keeps the bottom face aligned with the floor slab's bottom face and places the depth above it. The T-beam options, either dropped, inverted, or with embedded flange, allow a reinforced section with this shape to be defined by entering the following data: width, depth, left flange, right flange, and flange depths where required. And the dropped rectangular beam with variable section option allows us to define a beam with a certain width and initial depth that can be different from the final depth. Lattice beams are a type of beam with precast reinforcement. In the General Data menu, we define the features provided by the manufacturer. Among the available options, we find flat rectangular lattice beam, T-lattice beam, with right flange, with left flange, and dropped rectangular lattice beam. Pre-stressed beams have a precast base and form their complete section during concreting, together with the floor slab and the negative top reinforcement placed on site. In order to define them, we need to edit the pre-stressed beam library by clicking on the corresponding button. By clicking on New, we can define the reference, the geometry, the properties of the materials, both the concrete and the longitudinal reinforcement, and add the available section types. The following option allows us to define steel beams. In this case, we must carry out the material selection and the section selection from the options available in the program, which are very similar to those that appear when entering generic rolled or cold-formed steel bars. Additionally, if we activate the Beam Below Slab checkbox, the weight of the existing concrete will be added to the width of the beam. The last family, timber beams, allows us to use beams made out of this material. Using the drop-down menus, we must choose the section series and the wood section we wish to use. Likewise, we also indicate whether or not the beam is below the slab. Finally, once the beam section has been defined, we click on Accept. Now we must enter the beam into the model. The beam is defined by its initial and final nodes, so we select 2 points with the left mouse button. We can enter more beams by left-clicking the mouse again. To finish the entry, we right-click the mouse. At this point, the program will create a continuous beam with all the elements entered, if possible. A beam cannot be completely vertical. Furthermore, the angle between its local XZ plane and the vertical plane containing it must be 0, meaning a rotation around the longitudinal axis of the beam cannot be entered. The beam does not need to belong to a level, but if defined, the beams will be assigned to the nearest lower level. To enter a beam, we can also use the New option in the bar menu. Then, we click on the Central Editing button, and in the Structural Element Type section, we select Beam and click on Accept. We finish by entering the points that define the geometry of the beam as indicated.